All right, ladies and gentlemen, today we're going to be learning about balanced and unbalanced forces. Yesterday in our class, we talked about force and motion, and we talked about the two different types of contact force, one being applied, that's where I'm either pushing or pulling an object, and then the other being friction, which is a force that opposes a moving object. Today, and then there's one type of non-contact force that we talked about, which was gravity. That's what pulls us to the center of mass. So the larger the mass, the more gravitational force it has. Our Earth is gigantic. It has a very large mass, which is why everything on Earth gets pulled towards its center for gravity. But the ground is applying force by holding us up, so we don't go straight to the core. Okay. So our essential questions that we're going to cover today are: what are balanced and unbalanced forces? And how do unbalanced forces cause a change in position, direction, and speed of an object when acted upon by unbalanced forces? So just a quick review. A force is a push away from the body or pull towards the body to cause an object to either stop, move, or change direction. We have forces that push down towards the earth, that's our gravitational force, or that push upwards on an object, which is also our applied force. They may or may not cause movement. So for example, I have this book right here on the table. Let's go back. This book right here on the table, I have gravity that's pulling it down. So it's sitting on the table, but the table is applying a force from the bottom by standing there, and that is holding it up. So it's two types of forces on that object right there. Okay, a car accelerating. When the car is accelerating, you're pushing on the gas pedal and you're increasing in the amount of speed that the car is going and changing direction, which causes motion. So balanced forces. Balanced forces are forces that are equal in size, acting in opposite directions. Okay, so this isn't the best picture, and we're going to go over it some more tomorrow. But if I have an object that is centered there, and I have a force applying it from the right going left, and an equal amount of force on the opposite side, it's not moving. When an object is not moving, it's considered balance. Now, another thing, it could also be considered balance while it is moving. For example, if I have a vehicle and I am driving at a constant speed, the amount of force that is causing my vehicle to move is equal to the amount of force that is that drag from the wind and from the friction of the road. I'm constant. I'm moving at the same speed, even though I'm still moving. I'm not going faster, slower, faster, slower. Okay, so when I'm moving at that same constant speed, it can still be considered balanced. You have to be able to look at a picture and be able to determine, is it moving at the same speed or is it not moving at all? And if it's neither of those two things, then it is not balanced. These are some examples that we have. Okay, so we have a car that's not moving. I got this tiny little, cute little baby there that is just sitting there in the sun, sunbathing. I have a cup of tea that is sitting at rest. I have a motorcyclist. He's riding at a constant speed. And then I have this horse that's going at a constant speed and direction as well. Those are all considered balanced. Unbalanced forces. Unbalanced forces are two forces that are unequal. They are not the same in size and opposite in direction. Okay. They're always going to cause a change in motion in one of three areas: position, direction, or speed. So for example, let me move my little picture up here. You see these children on the picture that are playing tug of war. That's probably something we've all played. Well, if I have a couple of children on one side that are applying more force to pull that rope towards our end, compared to the other side, it's not balanced because one has more force than the other. Okay. So here are some really good examples of unbalanced forces. I have my little horse here. It says the direction of movement is towards in the direction that horse number 2 is facing, which is to the right. Okay, that means even though they're facing opposite directions, horse number 2 is stronger because it's moving in that horse's direction. That's unbalanced. Down here, I have a student exerting the strongest force will determine the direction of the movement. Which one is going to pull stronger on the boy in the middle? Whoever is pulling stronger, everybody's going to topple to his side. I have vehicles on a racetrack that are changing direction. Because they're changing direction, you're going to have to change the amount of force you're applying. You have to slow down or speed up, whatever the case may be. Therefore, it's unbalanced. And then I have just an object here. This box represents an object. To the left, it's 20 newtons. To the right, it's 10 newtons. If I do my calculation, which we're going to learn more about tomorrow, you're going to see that they're not going to equal to 0. Therefore, it's going to be unbalanced because my object would ultimately move to the left because the number on the left is larger. Net force, something we're going to get into more tomorrow, okay? Net force is the overall forces acting on an object. We measure that in newtons using what's called a spring scale, okay? This is done in a very simple way. First of all, I'm just going to take the two numbers and I'm either going to add them or subtract them. If they're going in opposite directions, either both coming in or they're both facing out, you subtract. If they're going in the same direction, like so, then you're going to add, okay? And that will get you your net force. So if I look at my little picture here, this person on the left is pushing at a force of 3 newtons, and the person on the right is pushing at a force of 2 newtons. Well, they're going in opposite directions. I'm going to subtract. So the person on the left has a greater force of 1 newton because their net force is 1. So how do unbalanced forces cause a change in position? Well, if it's unbalanced, then the object's going to be able to move. And if the object moves, then it's going to change its position based on that movement. Okay, so the example here is a skier at the top of the hill. While he's standing at the top of the hill, before he starts to descend, he's considered balanced. He's just standing there, he's not moving. Okay, but if another skier bumps into him, that's going to apply a force to him. It's going to cause this skier to move and fall down the hill, therefore becoming unbalanced. And then this unbalanced force caused his position to change because he is no longer at the top of the hill. He's now at the bottom of the hill. How do unbalanced forces cause a change in direction of an object? Well, if we use my skier at the top of the hill, it's, again, like we discussed, it's going to be balanced because he's just sitting there, or she is just sitting there waiting to go. But as the skier decides to point her skis down the hill and push off, she's going to apply a force to her skis that's going to help her glide down that hill. Therefore, she's changing directions to go move and is becoming unbalanced. So at the top of the hill, she's kind of more steady, like so. But then she pushes off and she goes down. And now that's a complete change in direction. And then this unbalanced force causes her to change her direction. How does it cause you to change in speed of an object? Well, as the skier is at the top of the hill again, remember, not moving, balanced, and he starts to go down the mountain, he's in an unbalanced force, he's going to gain speed because now gravity is going to pull him down faster compared to what is being the force that he applied, okay? So remember what we talked about, if I have a force of movement that's going in the same direction, it's going to actually increase in speed. We talked about that yesterday. So this unbalanced force causes him to change his speed.